In 1954, Anna Hodges was hit by a meteorite.
What time of the day was this?
12:45.
12:45. And this comes through the roof and hit you.
She was napping when the rock crashed through her ceiling and bounced off the radio into her stomach. Because it was small, her injuries were minor.
Ever to be hit by a meteorite, imagine that.
But much bigger objects have collided with Earth. 65 million years ago, a rock 10 kilometers wide slammed into the Gulf of Mexico, an event that likely caused dinosaurs to go extinct. Elsewhere, mammoth meteorites have been discovered everywhere from the US to Russia, and blasted craters in North America, Australia, and Africa. Falling objects from the sky have always fascinated humans, but they have also made us fearful, making us wonder whether someday a giant asteroid could come for us. In movies like Deep Impact and Armageddon, those fears are played out.
1 minute.
And heroes save the day.
We all gotta die, right? I'm the guy who gets to do it saving the world.
You might think this only happens in Hollywood, but that's not exactly true. There is a small chance, a really, really small chance of a large asteroid hitting Earth. So scientists are getting ready, just in case. Asteroids are hunks of rock that weren't big enough to become planets when the solar system formed. Smaller asteroids are called meteoroids, and when they fall through Earth's atmosphere, they become meteors. If they make it to the surface, they're called meteorites. Between 1988 and 2017, NASA counted over 700 fireballs created by objects entering our atmosphere. In order to detect asteroids, NASA takes multiple pictures of the night sky and uses computers to scan for moving objects. As Earth orbits, scientists make several observations from different locations to detect how close the asteroids are to Earth. Here, the nearest objects are labeled in green. At least 16,000 of them have been classified as near Earth, meaning they orbit within roughly a third of the distance from the Sun. And based on the object's speed and brightness, scientists can map a trajectory to predict whether it will collide with Earth. The impact energy of a 10-meter object, just a little smaller than a school bus, would be 100 kilotons. But the larger the object, the nastier the impact. A meteorite just a little larger than the Great Pyramid at Giza, at about 150 meters, would generate 288 megatons of energy. For reference, the number of megatons in the payload of the Castle Bravo hydrogen bomb was only 15. But asteroids don't need to hit Earth to cause damage. In 2013, a 17-meter wide meteor exploded over Chelyabinsk, Russia before it ever reached the ground. And the resulting shockwave released about 440 kilotons of energy that damaged structures and injured over 1,500 people. Following that event in Russia, US politicians called on NASA to ask about the threat of future collisions.
Well, if we saw one coming toward Omaha, what could they do about it? And they said they could use a laser.
First of all, it would not be practical to have a laser powerful enough to split it in half.
Their questions sounded like plot lines for a new blockbuster, but their ideas weren't actually that far off.
How far inland could a reasonably sized asteroid make water come in?
Scientists have analyzed how asteroid impacts would kill people, and getting hit by the ejecta, meaning space rock and other debris it kicks up, is one of the least likely ways to die. The most lethal cause is violent wind generated by the impact blast, followed by scorching heat and massive tsunamis.
The odds of a near-Earth object strike causing massive casualties and destruction of infrastructure are very small, but the potential consequences are so large that it makes sense to take the risk seriously.
All engines are gone.
In Armageddon, annihilation is avoided by nuking the killer asteroid. But in real life, our ability to prevent impact depends on how big it is and when we detect it. A 140-meter wide space rock is large enough to destroy a city, and if it were on a path to collide with Earth in less than a year, the only thing to do would be evacuate the impact zone. But if we are lucky enough to spot an asteroid 7 to 10 years out, NASA would have enough time to try deflecting the object, which they could do a number of ways. First, NASA could launch a spacecraft to act as a battering ram. And if the asteroid is far enough out, it would only need to be pushed a few centimeters off course to avoid hitting Earth. Right now, NASA is in the early stages of DART, the Double Asteroid Redirection Test, which will try out this approach by trying it on a non-threatening asteroid called Didymoon, which will pass near Earth in 2022. Another method would be using something called a gravity tractor, which pulls the asteroid in a new direction and points it away from Earth. Theoretically, a spacecraft could do this by hovering near an object to create a slight gravitational attraction that could be used to redirect the asteroid. The third option would be to go full Hollywood and use a nuclear device to vaporize part of the surface.
What you can do in principle, if you have a very powerful laser, is to cause jets of material heated by the laser to fly off of the asteroid, and that is essentially the equivalent of a jet engine pushing the asteroid off course.
So far, NASA hasn't found any asteroids big enough to threaten Earth, but we haven't been searching that long. There's still lots of space to survey, and the big one might be on its way. We just haven't found it yet.